Good evening, everyone. Welcome to the Wednesday stream. I trust we're all doing well. I can see there's a lot of love there for cat planets. Definitely have to do one. So, the past few days have been an absolute whirlwind for me, actually. I've been changing and optimizing the data structures for how all of our galaxy stuff and planet stuff is done in the game. It's one of those necessary evils when you want to expand a system and then you realize that the data structure you made for that system isn't quite up to par. So you need a few more data points, and of course that means changing things. So I think tonight's stream's mostly going to be me fixing things. But I'll be running through how things work kind of as I'm fixing it as we go along. So hopefully by the end of the stream, everything will be working, which will be nice. So where did this all begin? Right, let's take a look at the star systems themselves. So one of the things that we were doing and currently are doing, which is what I'm changing, is generating a lot of the information about planets and stars and things within the system that generates star systems. So you've got things like this text box here, and this is difficult to localize because it's all being generated like here and now within the star system code, and we're constructing the descriptions and things way before we ever get to anything resembling a UI, which just feels like the wrong way of doing it. So I'm moving more towards just generating raw data in the star system code and then extrapolating that raw data further down the line. So that raw data doesn't really get humanized until it hits a UI screen. And that just feels the better way around of doing it, and the more expandable way of doing it. So we've got where we had lots of expanded data points within this struct. We now have substructs instead, one for each aspect of whatever the large body happens to be. So, for example, we've got the physical characteristics, and as you can see, all these data points need some variables plugging into them. We are making the data now, so they just need plugging in. We've got the atmospheric data, and you can see that I've gone ahead and added some of the atmospheric compositions there. We've got some stuff about the surfaces, so we've got, again, some surface details there, along with also what type of ocean type it could have. Obviously, this all needs expanding a little bit. We've got the beginnings of our life data, which is kind of a big moment. So we've got a simple boolean as to whether or not the planet has life, what the tech level of that life will be based on our tech level chart, and then just a rough description of that life. This here is going to become massive as this system's built out. For now, it'll just be this, but it's going to get huge. And then again, we have our simple orbital characteristics. So all of those things combined create kind of the big picture for a large object within a solar system. So we've got a definition of large objects, which is essentially everything from a moon upwards. And then we'll also have one for small objects, which will be things like asteroids, space stations, alien creatures, that kind of thing. So fixing all of this is kind of the name of the game. And the other thing I did, which is in the star system side of things, I've started defining the type of object sooner within the code, and you'll see why in a minute. And also for black holes, which is what we're on right now, I'm taking the actual radius in kilometers of the black hole based on its solar mass, or rather the fraction of the solar mass. So things like the volume and the mass of that black hole is taken very much from the actual progenitor object that created the black hole. So that's everything from around about 3 solar masses up to, the biggest O-class stars. And the mass, thankfully, is actually quite easy to work out, because it's approximately 3 solar masses per kilometer of radius, and that's nice and linear and easy to work out. And the rest of it's as normal. But as we can see here, lots of things are broken because I've changed the data structure. But we look at our O-class star, we now have some new code for defining subclasses. So we take our temperature ranges in Kelvin, and then we apply a subclass for each class of star. So every class of star now has 10 subclasses, which means we've got something like 70 separate classes of star in the game now. Everything from O0V down to Y9. And by storing star class as a separate thing, because we've got a new enumerator here, which is like lots and lots of different classes. By doing this separately, it means we can pull that out as a data point further down the line. So again, rather than writing or describing what the star is as a text prompt, we're doing it in data instead. So the class of the star and the type of the star is all done in enumerators, and then when it actually gets to the UI, we extrapolate that into actual localized text. So hopefully what I'm doing now is going to make things like localization a lot more straightforward, because we're not kind of manually doing all the descriptions and the wordings for things. That's the plan anyway. The other thing is, so when we are generating the actual galactic data itself, we're talking something like 30 to 40,000 stars at a time. That's a tremendous amount of data to be generating. And obviously we can't do all of the star system stuff at that point. We have to do that later. So when we're generating the base data for a star system, we need to be generating the absolute bare minimum data possible. So what we're generating here, and I think I can probably lose the sector type because that's not really relevant to the sector location. So the location type is a new enum for location types, and let me just grab that a minute. So here you can see we've got everything from a star system, which would be a unary star system, a single star, up to an octuple star system, and then things like black holes, rogue planets, etc., etc. So things that will be added to this list will be things like a stranded starship with like a distress beacon, something like that. That's the kind of thing that would be a singular location within a sector. So each one of these describes what is in that 1 light year cube. Before, we weren't defining this as a data point separately, and that again is going to be something which would have caused problems further down the line. So by defining the location type, we are very, in a very granular way, defining what is this cubic light year of space. What are we putting here? What gameplay are we spawning within this space? And then when it comes to things like star systems, we're going to base this off of a primary object. So obviously we need to we need to draw the star in the sky out the window, and we need to list some kind of a star on the UI for the sensors. So even if it's a multi-star system, we still need a primary object that we're basing everything off of. So essentially that's the brightest, most massive object in that system. And that's what we define when we're generating the galaxy. So even if it's a multi-star system, we're not generating what type of multi-star system or what those other stars are at this point. That would come later. Yeah, and then these other data points are just, again, the actual bare minimum. Is the bare minimum that's needed to draw a star outside of the window. Anything that's not needed for that specific task, we generate later, which is where this comes into play. So this is basically the same data, but expanded upon, and this is what's generated when you actually click on a star on the sensors. So when you do that, it actually generates the full star system as soon as you click on it, and it takes a fraction of a second to generate, so you don't really notice that it's doing that. But it will generate the more in-depth information and all the satellite objects. So of course that's everything from other stars up to planets and moons. I'm not 100% on this data structure yet and how exactly it's going to work, because one of the things with multi-star systems is there are various different ways that can occur. So a binary system, simple. You've got two stars orbiting a central barycenter. That's nice and simple to do. And all of the planets simply orbit the same barycenter with the two stars in the center of the system. Fairly straightforward. As soon as you add an additional star and make it into a trinary system, or ternary, I'm not quite sure what the correct term is there. I prefer trinary, but it seems to be written as ternary. Not sure. But you could have a single central star with a binary orbiting it, or you could have a binary in the center with a single star orbiting that binary. And of course, either of those combinations could also have planets orbiting those objects. And that's where it starts to get complicated. And then once you add another star, do you have two binary sets orbiting a common barycenter, or do you have a single binary with an adjacent binary orbiting around it? And then you could add a fifth star to the mix, and then it's like, do you have a central star with two binaries orbiting that? It gets really complicated. So I think approaching it in the sense that maybe we start with a barycenter regardless of the star system, and if it's a single star, then that star is equal to the barycenter. Although even in our Sol system, the barycenter is slightly offset from the sun because of all the planets tugging on it. But for argument's sake, we would just place that star on top of the barycenter, and then just build a tree from there. But the question then is, what order do we generate the data in, and how do we go about deciding what type of binary or trinary or quintuple system it is? Yeah, and mass as well. Mass is a big one. And also, if you've got a single star, you can work out things like temperature regions really easily. If you've got a binary system, then it's not quite so simple, because you need to take the output of both stars, combine their light spectrum, and build the system based on that instead. I think it's fair to say that binary systems will definitely be next, and trinary systems will be much further down the line. Yeah, the three-body argument, or the three-body problem rather, is kind of a non-problem really, because there are no true three-body systems out there, apart from, in open clusters where star systems are still forming and they haven't actually settled down into anything resembling a stable system yet, because star systems self-organize into binary sets of binaries, essentially. So we should never have to work out a three-body problem, because they just don't happen in nature. They always settle into these multiples of two, which is always a two-body problem, which is nice for us, nice and simple. Yeah, but they're never true trinary systems, because you'll have either, again, a single central star with a binary orbiting it, or a central binary with a third star orbiting that. It's never a true three-body problem. It's always a multiple of two. Which is nice, because it means we don't have to do any crazy three-body problems. But the net result of making these changes is that a lot of the data points, i.e. on this, are now messed up because they were expecting data that has now changed. So I just need to pick through and make sure that those are all updated. So like these here, so we didn't have a data point for location type before, so this just needs to be fixed. Actually, one other thing I did while I was doing this is I set up black holes as an actual proper star system. So the game will now generate planets around black holes, albeit cold ones. Yeah, having black holes devouring a star is definitely something I'd love to do. I need to get a shader artist on board so that we can properly, do that justice. So I want to see a volumetric effect of, the star's upper atmosphere being sucked into the accretion disk of the black hole, and to be able to fly around that volumetrically in 3D. And that's beyond my skills, so I need to employ someone to do that. Okay, so that should be all the errors fixed with this particular bit of code. Yeah, because we're determining our cold distances by what the primary object type is now, rather than what the sector type or sector location type is. This one, however, is packed with errors. All of that lot. So all of that needs fixing. Oh, and the other thing I was doing, because I've been doing all kinds of stuff these past couple of days, I have defined, or was in the middle of defining, a data table for custom systems. In fact, I think I may have actually gone across, no, I did that on SQL instead. Because one of the issues, and the reason we have so many errors here, is like if we go to the Sol system, for example, you can see that all of the legacy structs now have all of these values that are no longer there. And I thought, rather than fixing those in place, because doing something like this to make custom SaaS systems is not in any way expandable. I mean, there's an upper limit as to how many of that you can do before it gets crazy. So this needs to be converted to a data source of some kind. And I was thinking data tables, because data tables can just literally have this struct as their structure. However, it would probably be better to do them with an SQLite database, because we can do a direct pull from our website and have the game do a copy of that and then load it locally, which means we can update backer systems and have backers be able to update their systems via our website, and then the game client just has to download a copy of that database and it updates automatically without us having to put a new build out in order to update the new Galaxy data. So I think I might just fix these in place for now, but ultimately that needs to be a SQL database. And at that point, we're kind of in the position where we can start implementing backer planets, at least in terms of their basic data. We don't have the in-game tool yet for designing the systems fully, but we should have the data structure there. So you could literally just go on the SQL file and start adding systems. Pedro, how long did it take you to learn to make a game like this? I started about 6 years ago with Unreal Engine. I'm 45 years old now, and I wrote my first line of code at the age of 5 years old on a Commodore 64, albeit copying that code from input magazines. I guess it's just been a hobby my whole life. I started off just writing mods for games. I was in an IT career anyway. I was a PHP web developer for a while. So I've always kind of been code adjacent most of my life. But I was made redundant from my job about 10 years ago now. Well, maybe a bit less than that, 7 or 8 years ago. And I decided to just throw myself into game dev, and yeah, here I am. Hi Cora, yeah, you're right in that in terms of within the game engine, a data table built using a struct would be perfect for what we need. It's using the struct directly, so all the data points are the same. It's within the engine, they're quick to read, and it would be perfect. The bigger issue though is that the database of backer systems, which is going to be a couple of thousand at most, at least a couple of thousand, is going to be sort of dynamic, because backers are going to be able to update their systems on our web portal. So say they have some changes they want to make, or they might be having their system change over time, so there could be some roleplay element to that. We obviously need to be able to first obviously check that that's been sanitized and there's nothing untoward there. But we want to be able to have that data available in the game without having to patch the game. So we also don't want that to be an online only thing. So we don't want the game to have to be online in order to get the data, in order to use the data rather. So when you basically load the client up, the client speaks to the website, checks the version number on the databases. If the website version of the database has a newer version number, it'll download that in the background, overwrite its existing database, and that then becomes the database it uses. if you load the game without an internet connection, it'll just use whatever version of the database it has saved. So in that way, we can implement the dynamic data for backer systems, whilst also retaining the ability to run the game offline. Yeah, and we have other things we want to do with external databases as well. So reading the backer data is one thing. Keeping the like the game credits updated is another reason. So again, if we get a fresh backer backing the game, we want to be able to put their name on the credits without having to push a new build of the game out. So again, that data needs to be available somewhere else on the internet where we can pull it into the game. And also we want to be able to have player hosted SQL databases where you can get players together in a group. If you all share the username and password between yourselves for your own hosted database, then the game can output data from all the different games into a central database. And essentially you're kind of making like a ghetto MMO at that point. So you can send data between all the various player ships via the SQL database, and do things like text communication between ships and seeing where those ships are in the galaxy relative to you. So you'd see them on the sensors. So it's not, you wouldn't be able to interact with them. You could see their ship in the world, but you wouldn't be able to target it or fire on it or anything like that. It would just be like a ghost of a ship in the galaxy. But at least it's like almost massively multiplayer. Almost, not quite. You just need to make sure that you have a group of trusted friends that you don't mind giving the database password to. I don't quite get that reference, Faux Flame. Is that from a sci-fi? I mean, that aside, we do plan to add all known exoplanets as well. And that'll be another database. Yeah, so if you are self-hosting a database for the game with a group of friends, then essentially all of your game clients will be feeding into that database, and it will use the registration number of your ship as your entry into that database. So say you've got 10 players and you've got 10 separate multiplayer games. As long as you don't keep changing the registry number of the ship, then it'll be outputting data based on that ship's registry number. So you would see all 10 ships in the game, and all the, where they are, what direction they're facing, and you could also have things like shared exploration data. So if one of those players meets an alien species and angers them in some way, then that species will be hostile to the other 9 players, because as far as they're concerned, they've met humanity and they don't like them. So it's just little things like that. I mean, there's only a limited number of things you can do with a SQL database, but you can do some things to join players' games together and make it more of a joint experience. But again, there does have to be an element of trust there, because you will need to share the database password between each other. But it's just one of those things, it's something that we can do, so, why not? It's an extra thing. Ah, from the Alien franchise, yes. Oh, definitely then. Although, I will be putting the Greys in that star system. Yeah, so if you have multiple games sharing a central SQL database, you won't be able to interact with one another in any way. So you can't board each other's ships, you can't fire on each other or anything like that. You wouldn't even be able to team up and fight the same aliens. For your game, that's just a ghost of a ship for you, but it's just that extra layer of multiplayer. So if you and a group of friends are all out exploring together, at least you can collectively explore. So you could be separated by thousands of light years, but you'd see each other's ships on the sensors. You'd see each other on the map where you all were, and any data that you scan will be shared between all those players. So if you scan a star system, that scan data is available to everyone else because it would be stored in the database. Something we do want to do within the game is have multiple smaller ships available in multiplayer. So you could have one group of players on one ship, another group of players on another ship, and go off and explore as a fleet. But I doubt very much we'll be able to have multiple ships as big as the Magellan, simply because of object count and memory utilization. So we'd probably have 2 ships half the size of the Magellan, 4 ships a quarter of the size, and so on. Calendar, yeah, exactly like that. So because it's using a SQL database, you can hail another ship and send a text message, and they would receive that text message just like email. So you can communicate in-game via text, but obviously not via voice or video. Hi, Mr. Brian. Good to see you on stream. Right, so I've got some fixing to do, haven't I? I'll leave these till last and just make sure that I've got the rest of it done. So this is what shows up on the sensors. So that's a terrestrial planet, gas giant, ice giant, and icy body. This is the more granular version after you have actually attended the system. I could just convert the enum to a string, which might seem worthwhile given that I am just literally converting to text what the enum is. Just wondering whether I need any additional wordage on there. Again, these all need localizing at some point as well. Carry on like this for now. The Sadarsky scale that we're using for the gas giants here, I'm going to change that so that it's more granular. So there are going to be subtypes within each class, because there are numerous different temperature bands where different types of clouds form rather, on a gas giant. And we kind of need to take that into account. I want to try and avoid having a game proprietary code or class system for planets and things. I want to try and keep it as like recognized science as possible. And I know that the Zadarsky scale isn't 100% accepted as recognized science, but I think it's about the closest thing we've got. Do you mean what music is playing now, or do you mean what do I generally listen to? Because right now this is Tokyo Lo-Fi Hip Hop by Lofi Geek. It's royalty-free lo-fi music on YouTube. What I would generally be listening to is probably something like Avatar or Korn. Maybe a bit of Slipknot. Yeah, so again with this, I made, or at least I started making, separate text fields for different elements of this description. So rather than doing it as just one big wall of text, split this up into just separate sentences. But again, I as much as you can do it at this point, it feels wrong to do it at this point. I'm sure it would be easier to work with in the long run if we did all of the actual written explanation of things on the UIs and not where we're generating the data. Now, fortunately, I have already done the hard work in generating all this data, so all we have to do is just drag it all out. Actually, I do need to calculate the mass separately, so the age separately from the star, because I've just been using the star age for all the planets, but they could of course be younger than the star. can't see it for looking. There it is. We are not actually calculating the bond albedo yet. That will be to come. So core mass, core density, core radius, and why don't we have volume? I forget to do volume. I shall have a look in a sec. And mass, density, radius. If yeah, looks like I didn't do the volumes, but that's fortunately easy to calculate. Welcome to the new joiners. Okay, there's a few data points missing there that I need to calculate. Not used for anything right now, so that's fine. Again, with the atmosphere, I've added the data points, I just haven't added the calculations for those yet. It was actually, when I was adding the atmosphere composition, I kind of realised with the gas giants just how much more granular it needs to be. Because if you take Jupiter, Saturn, Uranus and Neptune, then they are pretty much the same in terms of their chemical makeup. The ice giants have more methane than the other two planets, but generally speaking they're the same. And it's only the temperature which is driving their colour, because different upper cloud layers form because of the equilibrium temperature of the region of the star system they're in. So we need to take that into account with all gas giants, regardless of where they are, and have the equilibrium temperature really drive what the upper cloud layers are doing, irregardless of what their internal makeup is, because the temperature is kind of more important to what they look like. I apologise in advance to anyone that's cringing at this blueprint, because yes, I agree, it is unattractively messy. Right, so I'm going to hit delete on all of this. I'm just going to make sure that I'm not missing anything that I'm going to need. because again, things like converting Kelvin to Celsius and then to Fahrenheit, these things don't need to be done for the planet data. That's just that's literally only relevant to the UI display. So, and converting these to AUs, it's just not needed here at this point. So all of that can just be deleted. Gone. Let's come that node. Right, and now we can commit a bit of a tidy. Now, do we need star class here? Don't think we do. Can't think of any reason why we'd be pulling out the class of the star for the planets. Okay, so something else that's going to change rather imminently is we're going to do away with randomly generating a seed for the planet, and we're going off its local coordinates instead. So that will become the seed. It's much better to use the location of the object as its seed rather than just some arbitrary number, because that's a unique position in the galaxy. Do we need to generate a location ID? So we kind of need to know what number planet it is. And that's going to be an interesting one to try and determine, because if we are looping, so we're looping whilst we have mass, but there's no like iteration count on that, so we're gonna have to iterate an integer, I suppose, on there. And then use that as our planet number. But once we have multiple stars, and then we have multiple sets of planets orbiting multiple stars within a single system, then we're going to have nested integers, because you're going to have things like A1, A2, A3 for one star, and then B1, B2, B3 for the other star. And I think that's the way we'll do the naming conventions. We'll have stars as being alphabetical and planets as being numerical. Hey Leosh, good to see you on stream. Moons will be generated kind of around here-ish. So once we've determined everything we need to determine about the planets, we'll then calculate the Hill sphere and then populate that Hill sphere with moons. So I will say we'll probably take a fraction of the planet's mass and then use that mass for moons. So you will have correspondingly more moons depending on the mass of the world. Although that doesn't really work for trans-Neptunian objects, but then we'll handle those separately, I think, anyway. Yeah, moons as lowercase letters, I mean, that works. So our moon would be A3A. So capital A, 3, lowercase a. Asteroids and comets and anything else of that ilk we generated last. So where we're generating the main planetary system here, once we've determined the location of the final planet within the system, we will then go and do another mass loop for essentially a Kuiper belt. So every star system will have an equivalent of a Kuiper belt, and that's basically just the fringe of the protoplanetary disk where all of the last remaining kilograms of mass is just taken up with icy bodies that are just flung around at obscure orbits and inclinations. In terms of asteroid belts, this is a difficult one, because if we're going realistically, which we intend to, then asteroid belts aren't this kind of stereotypical science fiction environment where it's a dusty cloud packed full of boulders. True asteroid belts are, each object is separated by thousands and thousands of kilometers. They're actually very, very sparse. So we'll have to have a think about how we approach that. Maybe something kind of in between the two. I mean, it's easy enough to spawn objects within a system, so we can just separate, distribute maybe 100 to 200 objects within an orbit of a star, and just have them share the same orbit. And that is essentially a realistic asteroid belt. Yeah, and in terms of the volume, it's really down to just how much stuff we can spawn and have remain performance. I mean, fortunately, thanks to one of our moderators, Tristan, he's created a vector-based random seed system in Unreal Engine, where the vector itself generates the random values. So if you want a random float from stream, it takes that random stream from the vector, which means with the amount of vectors we have, we can have a unique seed for every square kilometer of a light year cube. So every square kilometer of an entire solar system can have a unique seed, which means we could quite literally have an object every kilometer and have it be unique. But the challenge with that is how much stuff can we spawn at once before it really starts to struggle with the object count within a solar system. I mean, ideally, if, and this is where we may have to incorporate or use the UI sensor range as an optimization tool. We could fill a star system with many thousands of procedurally spawned objects, but not have them spawn until you're within range of them or within sensor range of them. In which case we could manage the performance side of things by just not having those objects be there until you're near them. Yeah, things like ancient battlegrounds with bits left over, that's entirely doable. Well, it's not necessarily the render range that's the issue, it's the data generation side of things. So, like right now, we're generating a lot of data for every planet that's within a star system. And planets are big things, and they're there visible as soon as you enter a system, so that data needs to be available. But things like comets and asteroids, they don't necessarily need to be generated there and then. So let's say a star system had 10,000 asteroids randomly scattered throughout its sphere of influence. We can't have 10,000 objects appearing on the sensor's UI, and we can't go through the process of generating the vector location of 10,000 objects, because every time you pass into a star system, the game's going to hitch while it tries to generate the location of 10,000 objects. So instead we need to spawn those objects probably via a noise layer. So we'll let random noise define where things appear. And then as you're flying around the system, it'll be spawning and despawning things as you go, based on a given sensor range for the short range sensors. It's probably the most efficient way of getting a lot of objects in the system. Things like comets, which are perhaps more appealing and visually impressive, we'll probably just do those at the same time as we do the planets. So when you arrive in a system, you'll see comets immediately on the list of scanned objects. And then less interesting asteroids will just be scattered around. And you'll come across those as you come across them. But the other interesting thing with that is that we can also scatter things like alien derelicts and actually not have them beyond the sensors until you're within range of them, which means you could go to a star system, fly around a bit, and not actually come across them unless you spend more time exploring. So that could be an interesting mechanic. Knowing that there could be something there and kind of having a reason to spend a bit more time exploring. Right, let's fix these ones next. So we don't want sector location type. In fact, we need a whole new variable for this. What did I call it? primary object. Yeah, the performance hog of having a lot of objects within a system is kind of related to the fact that we're moving space around a static ship interior. So the more stuff you have in the system, the more stuff we have to move when you move the ship. So those things have to have their transform within the game world continually updated. So if you've got a few thousand objects, you've got to update literally 60 times a second as the ship's moving around. So that's kind of where the performance issue comes into it. But if you're limiting the number of objects based on sensor range, then those objects that are outside of sensor range don't need to be taken into account. So we can manage it that way. Right, that's that tidied up, but we do actually now need to set that as a data point. So pop that down there. Yeah, eventually when we have things colliding with other things, then yes, we will be adding damage to shields in the hull. So shields will be drained as you plow through debris. Right now the ship isn't capable of colliding with anything. Or rather, it is capable, it's just there is nothing to collide with in the galaxy. So all the stars and planets that you see out of the window, they don't have any collisions associated with them because they're not really there. They're kind of holograms of the real space that the ship is traversing. So the way it works in the game is you have a physics simulation for the ship. So you actually have a scaled down ship which helps with floating point errors. And then that ship physically moves around and can bump off of things like static planets within that space. Now, what you see out of the window, given that the ship interior is a static environment, is an offset of what the little simulated ship is seeing. So as that ship banks and rolls and turns, we move space around the ship. So we move space around the static interior corresponding to the orientation of the little ship, which gives you the illusion of flying through space, which is the only way we can have massive ship interiors filled with physics objects without the game dying. But doing it that way obviously has its downsides, and one of those things is you're limited in terms of your object count, because there's only so much stuff you can move around when the ship moves. And also we can't do real-time planetary landings because the planets themselves are being flung around as the ship moves. So we need to have a static ground environment that we transport the player to. But at least then, because it's static, we've got the full suite of UE5's outdoor environment tools to play with, which is really nice. Wayne, yeah, so right now, star systems are all attached to a central anchor point, which just happens to be where the star is. So as the little simulated ship moves around, that anchor point is moving. Now that means that at the central star, there are no floating point errors because you're literally right at the middle of its world origin. The outer planets are really, really far from their corresponding world origin, so surface textures and things get quite glitchy, which is purely down to floating point errors. But what I'm going to do in the next patch cycle, when I start doing sublight engines, controller support, and the ability to collide with planets and things, I'll be changing the way that works, so that rather than the entire solar system being attached to a single anchor point, each planet and object in space will manage its own position and orientation with respect to where the ship is. So what that means is, and bearing in mind that the true world origin is actually in the center of the bridge. So 000 in world space is literally the middle of the bridge carpet. So when you're flying towards a planet, it's effectively moving towards the world origin, because the ship interior again is static. So the closer you get to a planet, the closer it's becoming to the world origin, which means floating point errors actually reduce as you get closer to planets. So hopefully that will fix all of the floating point errors. Yeah, Star Citizen have physics grids, so they have separate physics simulations for the ships and the planets and things. So that's why you can have moving ship interiors within Star Citizen, because they have literally a separate physics simulation going on. We don't have that luxury in Unreal Engine, so we have to fake it to make it. Team Ruddy, what I'm doing in this stream is, other than just chatting, as we tend to do, fixing a bunch of errors which were induced when I changed the data structure. Because we had a lot more data that needed to be generated and nowhere to put it, so I had to really expand upon the structs that we're using to hold data within the game, and just kind of do a bit of a deep dive on how and where we're storing certain data points, with a view to kind of future-proofing some of that, so future editions become a little bit less painful. But as a result of updating all of those data points, quite a few aspects of the code are now expecting things that are not there anymore. So we're just going through and correcting all those errors. In fact, if I press play, well, there's one right there. Bad blueprint, bad. If we press play, I bet there's about 20 errors, yeah. So all of these blueprints are referring to data that doesn't exist anymore. Some of these are probably quite easy to fix, so just things like this. It's expecting a radius, but it's no longer existing as a separate data point. It's now existing as a separate struct. So the radius of a black hole will be under its physical characteristics. So here's where we have all the various aspects of a large system body, and that can be everything from a star to a moon. Obviously we're not using all of these data points for every object, So for the black hole, for example, only the radius really matters. So that would be that one, the body radius. The rest of them aren't really needed. That fixed that. But something that black holes do now have is planets. So it'll be interesting to see how that actually works. Because what I'm doing is I'm just treating the black hole as if it were a central star with a temperature of like 1 Kelvin. So it's only ever going to generate extremely cold objects around the black hole, but it will generate objects. So the idea there is that all of the black holes that are in the game right now, they're all stellar mass black holes. So they're all basically progenitor stars which have collapsed into a black hole, but those stars obviously had star systems. So what I'm doing is I'm working out the protoplanetary disk that would have been there for the progenitor star, and then when we replace that star with a black hole, I'm then basically deleting 75% of the protoplanetary disk mass, because the assumption is that the star would have collapsed, and a lot of the inner planets would have been sucked up into the black hole, which would just be leaving us with the outer planets, which should still be there within that system. So you should now expect to see an array of cold bodies orbiting black holes. Yeah, hopefully this will fix the nav errors, but that remains to be seen. We'll cross that one bridge at a time. Yeah, time dilation is not something that we'll be dealing with at any point within the game. We looked at it with black holes and how we could do time dilation, but it's really kind of beyond the scope of what it is we want to do. So we will make black holes scary. So black holes will have a physical effect on the ship, and it will try and suck you in. And we want to have gravity or basically mass play an impact on FTL drives. So if a black hole happens to be sucking you in, then there will become a point close to the event horizon where the effect of the black hole's mass is overwhelming the FTL drive, which means the actual FTL drive has an effect of 0 at that point. So even on full burn, you're still going to get sucked in. So they're going to become dangerous objects, but we're not going to go down the road of time dilation or anything like that. Yeah, it really depends. I mean, when a star collapses to form a black hole, that's kind of the opposite of a supernova. I mean, yes, it is still a violent event, but I don't think it's violent enough that it would strip atmospheres from distant objects from the star. Yeah, fair point, Fizzbrain, and I was also reading up on how black holes kind of take in mass, and the interesting thing with that is that in reality it's very difficult to fall into a black hole because matter speeds up to fractions of superluminal speeds at the event horizon. They exceed the escape velocity around the event horizon, so stuff doesn't fall into black holes very easily. It gets caught up in an accretion disk, but because of the speed element, it doesn't actually fall in. but we have to kind of make that whole gameplay distinction there. There are going to be aspects where we have to err on the side of gameplay over scientific realism, because otherwise it's going to be a very, very sterile environment. We also want well, yeah, there is that as well. And obviously, the black hole's going to have a Roche limit, and then whatever that Roche limit is versus the ship's hull, we can have damage applied at that point. But we want the ability to do science on a black hole to be proportional to how much danger you're putting the ship in. So if you take the ship close into a black hole, kind of within its accretion disk and within the point where the ship is actually physically in danger, then you're getting more valuable science from that. So there's that kind of risk-reward balance there. Yeah, I think we just want to avoid anything time dilation related. Because once we start down that road, you then have to think about, well, is the object you're scanning a few dozen light years away even there anymore? Or that star that you're scanning 1,000 light years away, does that actually exist now? So we'd rather just avoid time dilation altogether and just not have that be a problem for us. Yeah, gravitational lensing is definitely something we do want. I do have a tool that can do that already, but it requires that we take a cube map of the environment in real time and then apply that as a background, and then apply the gravitational lensing to the actual texture on the cube map, which is really, really expensive on the CPU. So I want to find maybe a post-process version of doing that instead. Right, what do you need here? So start off with temperature. Actually, that's not the temperature we're looking for. That's the one. I have no idea how Space Engine are doing it. You're right, actually. I did say I was going to update the home key. Now, while you remind me, I'm going to do it right now. Actually, did I do that on the player controller? I probably did. So I've got some of the input controls associated with the player character and some on the player controller, and I really need to merge those together because like there are so many inputs, it's hard to remember where they are, although I have just remembered that the one we're looking for is actually in the chairs. Where is it? Add it to the chair master. Yeah, using blueprints like this, in some ways, I much prefer it to traditional programming because you're basically programming with flowcharts, and it's so much easier to see logic flow when you're using flowcharts as your actual code. But at the same time, it can be quite disjointed sometimes. And like now, I can't remember precisely where I put the key bind for the home key when you're sat at the helm. I've probably looked at it twice already while scrolling through. I'm going to kick myself when I find it, I'm sure. funnily enough, this is exactly why I want to have someone else build the actual player character themselves. There's a lot to a player character within a game, and having a solid, slick, well animated and tight player character can really make or break a game. If your control method with the game, your actual interface with the game, is clunky and sloppy and difficult to maneuver, it just ruins the whole game. So I would rather pass this job off to a professional who's like experienced building solid player characters, and step away from that job myself, because I've done a lot of experimenting with it, and the result of all that experimenting and setting up lots and lots of separate systems on top of one another is that there is a keybind that I can't find that rhymed. Well, we know for a fact that it uses this input map. So if we look at the reference viewer, there. Well, unhelpfully, it's actually on the player character and the controller, so it's going to be one of them. Right, so neither of these would find anything for home. Oh, wait, hang on a minute. Just had a spark at the back of my brain. I think I actually stuck it on the Helm console itself. Which one would I have put it on? Wasn't that one? Was it that one? Might have been this one. Oh, yeah, there we go. There it is. Of course, right. So, again, this is a perfectly good example of how not to do something. So what I've done is I'm capturing the key press for the home key on the widget blueprint itself. So when you're looking at the UI and you press home, then it sets up, the actual coordinates for Earth, which works, but it's a really bad way of doing it. That you need a central processing blueprint for all of your inputs. So all your inputs should be stored in the same place, otherwise you get into situations like I just had where I literally couldn't remember which blueprint I was handling that input action on. So I kind of dug myself a hole that I had to dig myself out of. But again, that's why I'm looking for someone to build a proper AAA quality character system, so this stuff can get refined and polished. There's a big difference between working and working well. Right. So, now that we've established where the button press is being processed, let's grab the right values for it. Yes, Earth will be the very first thing on the list of saved locations. And yeah, a catalogue of saved locations is very much in the works. It's just I need to get around to it. It's quite far down the to-do list. So where is game state? There it is. Right, so this is the exact location of Earth. So we just need to make sure that we update this to reflect the exact same location that it's being generated. And Earth shouldn't be moving anymore. So the reason this kept changing is because every time we ran the script to extract the data from Simbad and the Gaia dataset, the math was turning up a slightly different location, because obviously we're having to convert the galactic coordinates on Simbad to galactic coordinates within the game. So the math kept coming up different. But we've been refining that. I say we. It's mostly been Unai on our server. Udai, sorry. So the work that he was doing has basically taken a few steps of iteration to refine it until we've got this precise location. So now that we've done that, that shouldn't be moving anymore. So the location of Earth should be set in stone. In fact, it is set in stone, literally, because what we're doing is we're using Earth as an anchor point, and then obviously positioning the planets relative to Earth's position. Right, there we go. So that's the home button matching the actual location where you start the game. And it looks like this is broke while we're here, so why don't we go ahead and fix that? I'm sure there's some fields missing there. To break our text fields. Right, so this is our target update, so we'll want to use the basic name for that one. Under the physical characteristics, we should find our body radius. That's that one. Assuming the same is broken here, although this isn't hooked up anyway, so we'll just do that. Great, that's another one fixed. Yeah, when I'm not on stream, I tend to spend a lot more time kind of just making these pixel perfect. Like, not there, but maybe there, but no there, because it has to line up with that. Do I have OCD? Maybe. I'm like, ooh, hang on, no, we can't leave that hanging off there. There we go. Next. Yeah, what I tend to do is I'll like this blueprint here, for example, is kind of semi-organized. You know, as things get set in stone, like this bit of code here is pretty much set in stone. So I'll box it, comment it, neaten it up. Whereas things which I'm still messing about with tend to look like this. As much as a pain this has been to have to dig this data out from a slightly more nested structure, having all that data nested rather than all in a big long list is much nicer to work with. Because otherwise you'd have all of these data points in amongst all this lot plus the rest. It was getting a little unwieldy. Going to have to sit there like that for now. My PC is an old i7 2700, I think. Oh, I can't remember now. It's about 10 years old. It's not top of the range or anything. In fact, if we look at my storage, you can see that I'm really struggling when it comes to storage, and I keep running out of space on all my drives. Sorry for blinding everyone. I always build my own computers. My very first job, like literally my very first job at 16 years old, was an IT service engineer, and I used to build and commission computers then, and I've done it my whole life. I don't know. Something feels wrong about buying a pre-built PC. Ugh, makes me feel all all unnatural. How the hell do you fill 29 terabytes? Apart from cat pictures, obviously. Anasi, no, the system that this is, it's all kind of connected to the overall planet system and galaxy system. It's a constant iterative process. So it will never truly be finished. There isn't really any such thing as finished. It's just there will come a point where iteration is no longer needed. I think that's the thing for me, actually. Like, I can't ever imagine calling a game finished. You just kind of get to the point where you stop working on it. It's never ever finished, because there's always something you want to improve. There's always something you want to add. Claire has told me that I'm not allowed to make an MMO. Because she says, if I make an MMO, then I will literally never retire, and I will be working on that MMO till the day I die. Which is true, to be fair. But I think I'd love to turn it into an MMO one day. I mean, that would be like Star Sim 2. I think it's crying out to be an MMO. We just don't have the money, the resources, the skill set, or anything remotely what you would need to make an MMO. Yeah, I don't intend to ever stop working on this, because it started off as a hobby and it will continue as a hobby. I work on it because it brings me pleasure to do so. It's what I do for fun. Yeah, we've toyed with the idea of just how far we can go with opening content creation up to players, and really the biggest issue with that is just moderation. I mean, Spore is a good example of what happens if you let players design creatures. I mean, there were like 1,000 different types of penis creature wandering around the game, and still are to this day. I even made one myself because I'm juvenile and that's what I do. I'm staring at this because I've changed the data structure, hence all the errors, and I want to make sure that what it's doing doesn't get affected by the change in data structure, because this particular blueprint is what draws all the live stars out of the window, so it's quite an important one. Yeah, this is the native blueprint system in Unreal Engine. Essentially, it's a visual wrapper for C++, and it runs, I believe, as an emulation at runtime. So the blueprint code is kind of running on a C++ emulator, which is why it's not quite as quick as native C++. Right, so I reckon this just needs to be transposed across to this. So we've got black hole, rogue planet. There used to be a process in Unreal Engine 4 where you could nativize blueprints at compile time, and it would compile actual C++ from the blueprints. But that led to issues, and you'd get things like something would work fine running in the editor, but then in a packaged game it wouldn't work right just because of nativization, and they were really weird issues as well. And they completely removed it from Unreal Engine 5, so you can no longer nativize blueprints. And yeah, I'm glad they removed it, because it never worked quite right. Blueprints run fine as long as you're not doing anything real time. So if you have an actor which is doing a lot on tick, then it's really, really god awful slow in blueprints. You want to be doing that in C++. So, on that note, anything that is doing anything on tick, we will be making in C++, because, that's where you want to be doing it. There's a whole bunch of stuff that I want to convert to C++, mostly on the optimization side of things. Like all of our lights in the game, for example, they're not doing code on tick, it's just a looping function, but that looping function is checking the whereabouts of the player, and it's either showing or hiding the lights based on the player whereabouts. But when you've got a couple of thousand lights all doing that, then it starts to add up in cost. If I was doing that on tick in C++, it wouldn't be anywhere near the cost that it is with blueprints. Although, across the entire ship, it's only costing like half a millisecond, so that's pretty good. Yay for optimization. And of course, in C++ you can do whatever you want. And with blueprints you can do whatever the nodes that exist allow you to do, unless you go ahead and make your own nodes. Yeah, well, the lights know what deck you're on, because I got a system that I made that manages deck awareness. So there are lots of things within the game that respond according to what deck the player is on. So if you're not on the same deck as them, then they go completely idle and stop doing what they're doing. Just little tricks like that make what we're doing possible. Yeah, all the optimization runs locally. So whether or not a light is rendered, that's a client-side thing. Whether or not a light is turned on, that's a multiplayer thing. Right, let's just add all these stars up. B, F, G, K, M, L, T, Y. Okay. Yeah, I've got quite a few helper functions I've written in C++ and just exposed them as a node. Sort of slowly building up my own library of helper things which just kind of get things done a bit quicker. So I'm just... This particular enum is essentially the primary object of a star system, and it doubles up as the large object type. So if there's a large object, i.e. moon upwards, it's captured on this enum. But because I'm kind of dual purposing it, it's missing things like nebula and rogue planet. It's really kind of... See, they're kind of the same but not at the same time, and I'm debating on whether or not they need to be two separate enums. I don't want to dirty the data by having things we don't need on an enum. Like, I've put the berry center on there because I'm going to need that at some point. That is kind of relevant for what's in a system, but like, these are supposed to be the primary object within a system. So really, we're not going to have an icy body as the primary object within a system. So for those purposes, that's really the wrong enum to be relying on. Yeah, animation states and things are something that need to be managed carefully in multiplayer, because if you've got all 200 crew members all in one room together, then all of a sudden you're having to render all of those skeletal meshes all ticking, and you have to replicate what those animations are doing as well. I've built a lot of optimization into it already, so things like the skeletal mesh animation rate will slow its tick rate down over distance. So the further you are from the skeletal mesh, the less tick rate the animation will be running, and the same for things like the nav mesh checking and all that sort of stuff. So every aspect of an NPC slows down the further it is from you. And if you kind of look at an NPC right off in the distance, you'll see that the animation rate is kind of noticeably slower. And of course, if you're not on their deck, because they know what deck you're on, they're not even rendered. All animations are stopped, and the nav data is only updating about once per second, which is an eternity in game engine terms. Right, I am going to duplicate this. So it's large object types. Where are we? Wrong folder. Here. So if we do this, so we want primary object types instead. Right, so they all make sense, that makes sense, all the star types make sense. Right, I will get rid of all of the planets. That one, that one. And then we'll call that Rogue Planet. And Nebula. So the purpose of this list is when we generate an environment, so a sector location, this is going to be the primary object, the primary mass within that location. Like Nebula is there and needs to be on the list because we do actually render the nebula as a sector location. So the center point of the nebula has to be represented. So the only other thing I can think to add to this list would be vessel. Station as well. Again, I'm trying to future-proof this as much as possible so that when it comes to actually adding these things, the data structure is already there for them. Again, the kind of the naming terminology within the game is a sector is 100 light years cubed, and each sector therefore has 1 million sector locations. So that's obviously 100 times 100 times 100. That gives you your million. And a sector location is a 1 light year cube, and that can contain any content that we choose to put there. So essentially that's any of the things on this list. Yeah, I don't think we'll go as far as having comets and asteroids in interstellar space. I mean, obviously there will be numerous comets and asteroids in interstellar space, but the speed at which you traverse that space means that detecting them, they're just too small and too out of your way to be detected. Whereas things like vessels and space stations will be emitting a signal that you can detect. Again, this is things like asteroids and comets and debris are things that you'd find within a star system. Now, obviously, yes, of course, they're going to exist between stars, but it's about the impact on stellar generation. So when we're actually generating the sector space, every type of object we decide to include within that space has to be generated when we generate the sector. So we want to make sure that the things we generate are at least meaningful. So if we were to add things like asteroids and comets in interstellar space, you're essentially flying up to a rock in the middle of nowhere, which is going to be pitch black because there's no star illuminating it. It's literally a rock floating in space. Now, I think the better way of handling that will be to do that procedurally, so that you might stumble across one just as you're tooling around. Like if you drop out of FTL and just fly around a bit sublight, you might come across a rock, within that sector location. So we're not having to generate those things beforehand because they're so small and so low mass on the sensors that it would be crazy to actually generate them and have them appear on the sensors. So yeah, this particular list is objects of note, and objects which are representative of content within the game. Ideally, this would just say star system, but this is the primary object within the sector. So we actually have another list, and the other list is sector location types. Where is that? There. So these sector location types, these are the actual content types that can be in the galaxy. So obviously you've got plain old single star system, multi-star systems, and these other bits and pieces. So a station or a vessel are points of content. There. So every cubic light year will be one of these things. Obviously 90% of them, if not more, are just going to be interstellar space. And obviously we want to make it so that interstellar space again also has the occasional thing, like literally just a rock, for no other reason than there's a rock there. Yeah, things like Oumuamua would be good to include. I mean, any famous object that we can include, it would be good to include. I don't know what the rights would be for things like the Voyager probe and things like that. We might be allowed to use it, hopefully. I mean, I think it's probably public domain. But yeah, all that sort of stuff, definitely. Right, so on here, so we definitely had Nebula that we needed to add. I think that should be everything, which means that primary object needs to be changed to primary object types. Now, and this is a really frustrating bug in Unreal Engine, and it's been a bug for such a long time, I can't believe they haven't fixed it yet. If you change anything about a struct, then any blueprint which references that struct will need to be recompiled and saved. You can change enums, fine, but if you change a struct, then it messes it all up. Fortunately, there's a workaround. If you, make sure I've saved the ones I need to save, if you just quit the engine without saving, so like all these things would need to have been recompiled and resaved. And of course you don't know which ones need compiling and resaving until it starts erroring at you. So if you just like literally don't save, quit the engine, and then reload the engine, then that completely bypasses the bug. Yeah, it's well, the bug happens if you save any blueprints that reference the struct. As long as you don't save them, it's fine. If you save them, then you need to recompile them. Such a weird bug. Will I ever have cam on stream? Yeah, once I've got my dev shed built, and we do have some news on that actually. We've got someone coming to lay a concrete base, I think within the next couple of weeks, which would be good. It's taken this long to actually find a contractor that will come in and do it. So we'll get a concrete base put down. It's about 3.5 meters by 6 meters. It's not massive, but that will be my dev shed. And I'll move my desk into there and set myself up with a camera and have a little streamer corner. And then you can look at my ugly mug while I'm streaming. So that needs fixing again, because this primary object there needs to be changed. Could have sworn I'd made that. Oh no, I didn't want to make it there. I wanted it to be local. would be nice to get Claire on the stream. I've told her before she should join me on the stream, and she always says that she'll never know what she's going to say, but I think it would be fun to have her on stream. We should peer pressure her into it. Right, so that should have given us a much better data source to work off of. So if we take that, you select on that, stick that in there. So we've got all the star classes. So then we've got black hole, rogue planet, nebula is hard set to 1. Stellar phenomenon is another one, but it's not going to be needed anytime soon. Yeah, absolutely, Delta. Yeah, Claire does a lot more than PR. She basically does everything that I don't do. So, when it comes to checking all the emails, dealing with all the comms, basically handling a lot of the business side of things that takes time away from development work, she'll pick that up for me. So she's like a company secretary, I suppose you'd say. She does HR, she handles like all the job applications that people are sending in. She's had to go through, like for concept artists, I think about 150 applications over the past couple of weeks. Go through them, check out all their portfolios, send no thank you emails to people that aren't suitable for us. It's that's a lot of work to do that would take me away from developing the game. So it's great that she's able to do that, and so I can focus on development. Wow, sorry, yeah, 213 applications she's had to go through so far. And that's just for a concept artist. We've got like 4 or 5 other roles that we're recruiting for, and that's probably going to be another set of 200 odd applications. I need to make sure I get this bit right, because we're scaling things out of the window based on their class. So that one is O class stars. That one is B class stars. And all the rest of them are unaltered. So we've got planet. And then just a planet. It's true, actually. Since the game development has really taken off in a big way, we have way too many takeaways. And that's just a time thing. It's like, it gets to like 5 p.m. and then it's like 6 p.m. and we're still busy working on stuff, and it's like, we just haven't got time to cook. Let's call a takeaway. It's not great for my figure, I can tell you that much. I've just spotted something there. It's lucky I did, because it's going to loop through all of the sector locations. So this is, again, all of the 1 light year cubes that contain content within a sector. And it's checking to see whether the location type is a nebula. And if it is, it's going to spawn a nebula static mesh. Now, that would mean it would spawn 1 nebula for every single star, which we absolutely do not want to be doing, so I want to be making sure that that is a nebula instead. That would have been a nasty one. Hopefully those are all happy with the new data structure. Alright, fine, I'll fix that one. bit of code I'm doing here is the size of the stars that show on the holo display. So just making sure that they reflect their previous values. I was scaling them off of their actual radius at one point, but they're so small that the difference is so little it's easier just to set the scales manually based on their class. I might just go ahead and make O class the biggest. Tweak that a bit. It's no longer a bad blueprint, although it is down there again. Why does it keep going down there? It is a bad blueprint. Stay where I put you. Now this is a good example of where the new data structure actually works really well, because I can just pop that in there. Okay, so this is an example of where I need to construct the actual description for the UI rather than in the data. So this is for the long range sensors. Right, so this is the scan data. So this description here, that would have been the wall of text that we were doing previously. So right, okay. So we need to basically need to reconstruct that wall of text. However, what I want to do is, rather than have it as a giant wall of text, I want to actually split it into nice neat boxes. So at the moment it's this. So this box here basically, so this text box here displays all of the text from the sensors, and it's literally just a text box, nothing exciting about it. What I want to do is actually format it nicely and put borders around it and actually separate the data out into like a proper data structure. So you've got the physical characteristics, the orbital characteristics, and the atmospheric data, all as separate boxes, to really kind of present that data more neatly. And all of that needs to happen here. So I think for now, given that this is the scanned data, although it's on the long range sensor, so we don't want to use the scanned name. So this is going to be loads and loads and loads of stuff. So I think we'll condense this to a collapsed node because it's going to be massive. Build sensor scan output. This innocuous little box can then be massive. All of that stuff. All of that stuff. All of that stuff. That stuff. And all of that stuff. I think, in retrospect, I might go ahead and put the orbital characteristics under the physical. Kind of seems to make sense that it would be there before we delve into the nitty-gritty. Go with the same naming convention I've used there. Basically, all that is going to be a huge long list of all the data points, which I won't bore you with at this precise moment. I'll go back to filling that in once we get the actual all the errors fixed. Obviously right now, wall of text, and then what I'll do is I'll break those walls of text up into those separate boxes. So by the time that it's polished, it should all look lovely. Okay, that's another error gone away. With the text boxes, if you click the little flag, you can select a strings table. So you can actually have separate strings for any of the text in the game, and then just have a localized strings table for each language. Like where I'm a little bit sketchy on how to implement that is I need to be dropping variables in the middle of the text. So if it's just a table of strings, that's not going to take that variable into account. So I may need to do a string before the variable and then another string after the variable and then join them together. Yeah, I'm not sure if Unreal can do that with string tables. I've literally never used them before, but I'll have a play with them at some point. Based on our demographic, our three top countries are the UK, the US, and Germany. So Germany will be the first language that we localize. I think this is actually the old code for this. So it actually probably isn't used anymore. But, it is odd that it's referencing it. I'm going to park that one for now. This one we definitely are using. Just thinking, because we've got see, we've got the star class now. I can actually stick the actual proper star class into the name. Now this is L0 we're working on, so I can actually put that in there. So rather than using that, if I format text like so, and I just put that in there like that, it will actually give us our proper like G2V class star kind of output on the sensors, which would be nice. This was another chicken and egg thing I ran across, in that when we're generating the basic sector data, so this, at this point, all we know is the temperature of the star and what type of star it is, as in, is it an O class, whatever. What we don't know is the subtype within that class at this point. So when you look at the star out of the window, all you're seeing is O class star, B class star. You're not seeing like O7V or B2V, because that isn't actually calculated yet when we generate this data. So I'm going to have a look at what kind of an overhead that actually is generating that at this point. I mean, it is just a lookup table, but it's a lookup table for every single star. But if we can define the class here, that would be nice. Obviously by this point we are defining it. This is an example of something else which is going to need iterating upon once we have multi-star systems, because this might be a barycenter rather than a star, or this could be 2 stars, and we need to take that into account. For now, we only have single stars, so that's a problem for future Dan. Try and get these the right way around. So that one is the basic name. That one is the scanned name. Okay. It's not connected to anything. So the orbit average distance would be in our orbital characteristics. That's what I prepared earlier. Okay. What on earth was it even trying to do? I can't actually remember why I was doing this by class. It doesn't seem to make a lot of sense. Why not just put the name in there? I bet I was doing that for a reason, and the reason why will probably become and bite me in the ass at some point, but there we go. Another problem for future Dan. Right, okay, we're down to our last two problematic blueprints, and this shouldn't be too much of an ordeal. This is just the primary object type no longer exists using the same enum that it was, so we just need to go and update those references. Balls. Means I have to delete all of them because the base enumerator is wrong. apologise for the lack of talking. I am deeply concentrating on the clicky clicky. Should be all of them done. So that doesn't matter. That's a B class. Next. Go away. A class. Next. When you're rapidly going through things like this is when mistakes happen. Right, okay. So we should be down to one errored blueprint now, just that one. And we know why it's errored, because of Earth, funnily enough. Yeah, so that's all fine. So we need... where is it? There it is. Got this little nightmare to fix. I think Sol's a G2V. I better Google it to be sure. Sol star class. Yes, it is a G2V. Basic name. Sol. Camp name. Sol. Okay. No, I don't really know what I'm doing. I'm just winging it. Blah, 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 blah. Actually. See, this is interesting because before I've just been dumping all this information into a text field. Yeah, I am putting it in there, so that's fine. Yeah, so things like this are just not needed now. However, some of the physical characteristics are. So body radius is definitely one of them. And temperature, which goes in there. And also goes in there. That's annoying. If you collapse it, it wipes out the things you put in. Whew. Radius and temperature. Well, that's wrong. So the description stick that in there in case it gets pulled up somewhere. So I know that this is going to be missing from the sensors now because we're no longer generating the text description here. But that's fine because we can build that separately. I think what I'm going to do is probably use this field for flavor text. So we'll build the main description. Yeah, it doesn't have an atmosphere. I was using an atmosphere component on the star, but it starts breaking on those scales, so I've had to stop using it. Yeah, so I'll use this as flavor text because on the Sol planets you've got things like that text there. Just a nice little bit of flavor text for the worlds, and I think it'll be good to include that in the data. But it has to be included in the data because that's not the sort of thing you can generate procedurally, except it will be for the life stuff. So that field needs to go into the description field, which is in here. Just trying to think ahead here as to how I can make sure I do this expediently for all of the planets. I think what I will do so if I make it a macro maybe. So a lot of this stuff can just be input into a macro. don't actually need to set these as variables before plugging them in. We can just plug them in directly. If I leave that out, and I take all of that, make sure I don't grab anything else. And, right, so we collapse this to a macro. And let's make manual planet. This is actually a temporary thing because all of this data will be in a SQL database. So doing it like this is a really poor and really not very expandable way of doing it. So dumping all this data into database and just reading it from the database means we can add Earth and all of the backer systems really nicely and easily, and have a data structure we can manage. Imagine doing this 1,000 times, it would be an absolute nightmare. It is SQLite, yes. It's just literally, it's just going to be a SQLite file stored in the content directory that the game will read at runtime. So you could actually add your own planet systems, well, add your own full star systems just by adding them to the SQL database. We want to make a little float. We want a local float. Why can't I make a local float? I can't spell apparently. To get rid of that, sign that. That should be global variable. Yeah. That goes into there. So all of that shouldn't need to be made as variables. Don't care about that. That can go in there. We make a bunch of structs. Giant data sources like this are really ugly to work with. It's kind of unavoidable, really. Don't want to get rid of too much stuff, so things like semi-major and semi-minor axis needs to be as input to the macro, so that's fine. That can just stay as a random value. So we float for semi-major axis. Semi-minor axis. I'm supposed to be able to do the inclinations as inputs as well. So that's the system inclination relative to the galactic plane, and that's the planet inclination, or the orbit inclination relative to the central star. Right, I don't want to lose these values for Earth, so let's just pop them in as I go so that I don't delete them by mistake, because I don't want to have to look them up again. So 63. Okay. So it's going to be a bit of a big macro, but it saves a lot of messing about for the other ones. Which means that that can go in there, that can go in there, that. I already put that in there, so that can all go. Don't need none of that. So basic name Earth, scanned name Earth. I'm not using those two, so that's fine. Get rid of them. Do the thing again. Do not press that, it's bad. Right, so the galactic coordinates we know already. The local coordinates actually come from there, so I can plug straight in there. And the orbital characteristics really need to go up the top, so let's move the order of them around a bit. And I think I'll change the order of that on the struct as well, just to keep everything neat. So this can all just connect straight in here. Need to calculate the orbital periods, actually. I'm not doing that yet. Right, so that's all that stuff. Equilibrium temperature for Earth was 255. Quickly Google that. Equilibrium temperature 255, yes. Oh, but of course, there's no point me writing it in here, is there? Because I need to do it on here. So you want basic name, scanned name, description. Done that one, done that one. Okay, so we need our radius. And we need atmosphere opacity and temperature. That will go in the atmospheric data. So radius goes there. So obviously it does have an atmosphere because we're currently breathing it. And those are actually the same as the defaults, so that's fine. Last thing is fine. Does it have rings? That's going to have to be a variable. Stick that up here as well. First things on the list, so that can go up top. Those things are consistent for all of them, so that can stay as is. Yeah, it's funny you should say that, actually. I was watching a video a few months ago now where a guy was talking about proper naming conventions specifically for Booleans. And I don't know, it's... Yes, the question mark is implied because it's a Boolean, but me just working with it, I don't know, the question mark makes me feel happier. It's like I don't know. It's a safety blanket. I like the question mark. It's a question. Does it have rings? It's an emotional security question mark. I mean, that should be enough data for the basics. Just wondering whether do I fill it all out? I mean, I could just fill it all out. if I can do actual powers in there. Oh, I can! Look at that! Brilliant. The other thing I need to do, actually, speaking of non-alphanumeric characters and variables and things, I need to put the units on these, because when you're building especially with the procedural systems, like defining the temperature regions and things, like without the knowing what unit of measurement your variables are in, it gets confusing really, really quickly. I can't remember which one was giving me grief. Could have been this one. Yeah, it's things like, your temperature in Kelvin, and you need to know your mass in kilograms, and then that's kilograms per meters cubed. And knowing the unit of the variable is just a huge, huge help. So, yeah, I need to do that more often. Earth analog. Funny that, it's Earth. So all I need to do is this for all of these, but now that I've made it a macro, I should be able to just fill in the boxes, and it'll do the rest for me. I just realised I'm filling out the details for Earth, and it's kind of meaningless because it's going to apply that to all of the planets. I'm going to zero these values out a minute, because it's going to confuse me further down the line otherwise. I shouldn't need any of those yet. At least not just to make it work. Right, so Sol is done. So next up we'll do Mercury. All we do is we take our handy dandy macro, don't need that, we do need these, pop that in there, 3.38, doesn't have an atmosphere, and its temperature is definitely not 288 degrees. That's a point. No atmosphere. And then, yes, you do have an atmosphere. Hang on a minute, I just realised that I've literally just deleted the flavour text that I needed. It's a pain to undo all of that, but I needed this bit. Like now I can delete all that. Let me just go back and have a quick look at Zelaf. And the densities. So I'm not multiplying by Kelvin. I'm using the Kelvin temperature to define like the mass ranges. Basically, as I kind of intimate with this here, so the inner portion of the protoplanetary disk is higher in dense materials, and there's also like a magnetic field factor at play there. So because of the magnetic field of the protoplanetary disk, higher quantities of iron are in towards the inner disk. So what we're doing is we're using the Kelvin value at the equilibrium temperature to kind of drive the iron quantity of the planet's core. So 7860, that is the density of iron. So at the worst case scenario, our planetary core is as dense as pure iron, and then of course we multiply that even further based on the mass of the planet. So if we're like essentially a pure iron core, but the planet itself is absolutely huge, then we're multiplying that value by 3 because we're compressing that iron down into an even denser material, and that gives us our core density. Now multiplication works because you're basically, again, because it's a mapped range, so this is the range of planetary densities. So that's essentially 1 Earth or just below Earth, I can't remember now. So that's basically, you know, multiplier of 1. So this is a fraction multiplier. So close into the star, a whole bunch of iron multiplied by 1 for a low mass, and then a whole bunch of iron multiplied by 3 for a high mass planet. So you're basically multiplying the density to make the density a greater value. So Mercury, blah, 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 radius. Doesn't have an atmosphere. That's all fine. Should be everything actually. Oh, temperature. Yeah. Done and next. Yeah, I always try and multiply whenever possible. Sometimes it's like if I've got a formula that requires a lot of division, I just stick with the division because maths isn't my strong point and I don't want to be converting all the divisions to multiplications. And we'll try and speed run this a little bit because I'm sure it's not particularly exciting watching me fill in boxes. It's done. Next. The atmosphere requires a different color here, so I just need to change that. Atmospheric terrestrial planet. Right, so we need so it's 215.8530. To give me a default, is it? Where's Earth gone? Question actually, can you even set defaults on macros? I don't think you can. Oh yes you can. Aha! 180.75. See, that's a good example of how everything crashes when you don't want it to. Oh, how much of that was unsaved, I wonder. I was about to say, it's a good example of how you learn something new every day. Like, today I learned that you can set default values in macros. Right before Unreal Engine slapped me in the face. There's no point clicking restore because it's not connected to Git. And I've never been able to get that to work. Yeah, we're very close to an engine test. I just need to fix the earth data. Although, to be fair, I could disconnect the earth data and just run the test. I mean, we should just still have the one broken blueprint. Yeah, good. Phew. At least I saved it after doing Mercury. That is a relief. Yeah, I do all the source control outside of the engine. I use GitLab. I did try doing it in engine because you can literally do side-by-side blueprint comparison to see what's been changed on a per blueprint basis. But it just wasn't working reliably for me. I don't know whether I didn't have it set up properly or whether it's just generally buggy, but I found just using GitLab outside of Unreal just works, and I'm happy with it. So what was that? 215.8530. Was 180.75. Oh. Yay for not crashing. Save just in case. Right, did we capture everything on here? Not the temperature. So capture everything else. No, radius. Okay, Venus, your turn again. Oh, that's fine. That can stay 0 on Mercury. Yeah, it's fine on Earth. prepare all of these ahead of time, just to speed the process up a little bit. Hey Christopher, I am currently working on a refactor of the data structure that we use to store all the planetary and star system data. It's kind of a necessary evil at this point, because as we're building out things like life on planets and that sort of thing, we need more data points like atmospheric data. And the data structure we were using was beginning to get a little bit overwhelmed by the amount of data we had. So I needed to split like a monolithic list of variables into separate structs. So we've got things like physical characteristics of a planet and its orbital characteristics as separate structures within the overall data, which just keeps it a lot cleaner and a lot more easier to work with. But as a result of doing so, all of the blueprints that use that monolithic list of data are now confused because the data is no longer there when they expect it to be. So I now need to inform all these blueprints of where to find the data, because they do get themselves confused quite easily. Stick one of them in there. I suppose I better do them one at a time, otherwise I'll get myself out of sequence. Right, so Venus, atmospheric terrestrial world, Venus and Venus. Grab our description, pop that in there, get rid of that now. No, I don't want to edit the thing. Venus has an atmosphere, capacity of 4. Do radius first. Radius. Temperature. Blah, 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 blah. Done. Next planet. Save. Next planet. Atmospheric terrestrial world. Mars. Mars. Wash that in there. Connect that up there. Whack that in there. .5. Don't need that now. Don't need that now. So 60.33. I'm sure that was supposed to be 10. 10, 113. Next. Oh, yeah. I'm glad you're watching because you're obviously paying more attention than I am. Happens when you rush. No atmosphere on series. Temperature of 110. Radius of that. Need that. And done. Next. Oh, you most definitely are. There are so many times when someone will just point something out and it's genuinely useful. Oh, derp. Forgot to do that almost. I did set that as a rocky world, didn't I? Atmospheric, terrestrial. Yeah. Oh, actually, it's not a terrestrial planet, is it? It's a dwarf planet. When I first started streaming, one of the things which I was really nervous about was doing anything that required actually having to think about it, especially when it came to things like maths. Because, you know, as I keep saying, maths is not my strong point, and you know, I'm terrible at mental arithmetic. And, you know, generally speaking, I need a calculator for everything. So, you know, having to do mathy stuff on stream is quite daunting. But I guess I learned to just not care. And, you know, if I mess something up, then, oh well, I've messed something up. Never mind. Life goes on. Fix it and move on. So there is. See, things like that. Granted, I'm rushing through this, so I wouldn't normally be quite so haphazard. But yeah. Oh, this is an interesting one actually, because Saturn and Uranus have quite specific rotations. I have to add that on there, aren't I? Body rotation can go under radius. That's 5 minus 10 is 0. Actually, while I'm at it, I may as well set the default atmospheric capacity to 4. It generally always is. I had a variable a while ago. I can't even remember what it was for originally, but I called the variable, "Why won't you work, you bastard?" and completely forgot about it. And then like stumbled across it 6 months later and was just like on the floor laughing. Never did get it to work. Another fun bug. So randomly, and this is something that's kind of started happening with UE5 specifically for me, is sometimes blueprints just get themselves to a point where I can't delete stuff. So press delete, it will not go away. And I can't duplicate it or copy it or paste it or anything. That node is now stuck, it will not go away. If I like compile, save, close it, reopen it, it's usually fine. But there you go. See, now I can delete it. So weird. UE5 is gonna UE5. why don't I have a rotation on here? I have to Google that. Straight up 90, so that should do. That should do that. Ice giant. There you go. Saturn can have its rings. Nearly done. Where are you? It does, yeah. Should be ticked. Tickety ticked, yeah. To be fair, so does Jupiter, and that needs rings too. All 4 gas giants have rings, albeit quite faint for the other 3. Yeah, if you tick has rings, then it will procedurally generate rings. Although that's actually it should do, because I made a unified planet actor, so it should very well do. Let me just check these a minute. Yeah, tick 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 tick. Good. Okay, Pluto. Pluto does have an atmosphere, but not in terms of the game. It doesn't have any rings. Okay, that should be all of the Sol planets done. Hoorah! Oh. Thank you. Icy body. those. Okay, well that reduced the screen bloat somewhat. Right, so the other one that's going to be erroring is Lasai 9352. But for now, I'm just going to unhook that one. See, maybe clear up some errors. Missing a couple of bits of data there. Yeah, this is Lofi Geek. They're actually really good about letting you use their content. All you need to do is just drop them an email and just let them know your channel name, and they'll remove you from copyright strikes and things. That would be very funny, actually. Yeah. Not sure if we get permission to put it in a product like that, but yeah, worth asking maybe. I'm going to delete all of the text. And then this is all going to have to be sanitized. So we are setting the galactic coordinates, so that needs to go in there. We can use our star class for this one. Yep, that gets the name in there. Oh, I love deleting code. It's my favorite thing to do. I say it's not used anymore. I might very well refactor that for flavor text, but we will see. Actually, on that note, on the Sol system, yeah, I think I definitely will use that for flavor text. Okay, what else do we have problems? What are you? So if this is literally just the class name, then yeah, only needs to be that anyway. Need that. Well, actually, we do kind of need that because It could be a black hole. Yeah. That makes more sense. Next. Yeah, actually, so this one. Not even using that now, so that can go. Not required. What are you? Okay, so we're doing set to location type. Needs to be replaced by because LTYs have a different actor. I need to merge those two together at some point, so they're not separate actors. So we need EP star static mesh. I select that object, so I can do another thing I learned recently, which you can do that. Hurrah! Oh, no, not that one. Don't want to do a little bit on there. Right, same deal here. So we just need to use the different enum. Not actually quite sure why I'm doing this, because I'm already specifying the exact class, so why am I describing the class? This might very well be a redundant bit of code, so I'm going to have to remove it, but I'll just fix it for now. So your custom classes. Static mesh. Memory serves. I'm just using this to choose what to spawn, but again, knowing the actual class, it's kind of redundant. We're almost down to the bottom of the errors. funny story. So the character Dan in the Orville puts the elevator music in the elevator, and you get that kind of cheesy music. Well, when I was making the Orville fan experience, I found that same exact piece of music and put that in the elevator within the game. And of course, me being Dan, I literally was Lieutenant Dan in that moment, and that music is still there in the game to this very day. That is a big number. That's how many kilograms Sagittarius A star is. That is a chunky black hole. Why can't I see it? Oh my god, it compiled finally. Hurrah! yeah, some of the things in space are just mental. One of the fun things, of course, is that Sagittarius A star is also surrounded by black holes that are orbiting it. One of the biggest, like, super, what do they call it? So rather than being a stellar mass, it's like superstellar mass. Like, it's nowhere near Sagittarius A star, but it's like 300 to 400 sun masses, and that's orbiting Sagittarius A star. Yeah, that would be a floating point error. So even though it is a 64-bit float, it's still, it can't handle numbers that big. Yeah, home button. Right, so Earth is there. That's wrong. There are no stars being drawn, so that's interesting. The Sol system is correct, but it looks to me like all of the stars are somewhere else. Let's have a look. So they are where they should be on the sensors. So yeah, they're all exactly where you'd expect them to be. That is a lot of stars. The LTY classes need their size adjusting. I'm not sure what that is. It's too big, whatever it is. Do we have any... Ooh, hello. What's going on there? Okay, so yeah, we do have planets, and they won't be generating anything yet, I wouldn't have thought. Yeah, so... few bits and pieces to fix there. Thank you, Alan. It's appreciated. So everything's where it should be in the galactic space, so that's fine. I think what you're looking at there is an error with the code that renders things out of the window, so that's an easy one to go and check out. If I press the home button on the keyboard, it takes us to exactly where we are, like down to the square kilometre, so that's good. So my GPU is a 2080 Ti, and as I say, I've got a relatively old i7 and 32 gig of RAM. Okay, yeah, Earth is all working. I think we've got temperature to display. No, we don't. Right, so I need to fix the temperature zones on there. I imagine that's just a unit conversion thing, so it's probably a centimetre to kilometre conversion. In fact, it looks like, yeah, it looks like they're all tiny in the middle there. Anasi, yes, absolutely. So the thing that was preventing the dev builds is obviously the game wouldn't run because of all those issues that needed to be fixed. They are all now fixed, and the game will now run. So hurrah! Just want to fix that. So the stars are all displaying, but the planets are not. So just need to see why we don't have planet names, but that should be relatively simple to fix. And then why do we not have any stars? Or more specifically, why are they all over there? Should not be over there. I turn off those. See that all the stars are hiding over yonder. They're all okay there. Yeah, perhaps I made Sag A star too big and it's just sucked everything in. Let's nuke some tabs. Right, so the first problem is we're not getting any planet names. Is that because I haven't actually set them yet? Planet name. Oh yeah, look, that's why they're all blank. So terrestrial planet. Of course, I did set them, and then it broke. Gas giant, ice giant, capital ice, and icy body. And I really can't be bothered to type all that again, so I will cheat. So my plan for the next stream, by the way, is to actually start populating this. This is the exciting one. Actually putting life on these planets. We're so close now. We're so close to doing this bit. Just needed to get all of this data in first. Then we can do this. Let me just chuck some variables at this a sec. So there's the mass, there's the density, take the age of the star as our planet age for now, temporarily until we calculate our own planet age. I think we neglected to do planet volume for some reason. Oh no, we didn't. We just didn't do the individual volumes. Gravity. Not how you spell gravity. Right, if I just stick them in for now. Right, so this should fix the sensors display. Hoorah. Okay. So something I need to do with the ice giants actually is I've capped the size of the ice giants to like 0.4 of Jupiter, and that's just not realistic because ice giants can be just as big as Jupiter. So that needs fixing. But we have stuff, so it should be telling us a little bit more information now. Yeah, so we've got our ridiculously large mass number. Density coming up as 0 is worrying for a gas giant. What about a terrestrial world? Also 0. Oh yeah, I forgot that. It's listing procedural planets for Sol, which is weird. Okay. Well, I'm happy to put a build out with missing data, that's fine. I do, however, need to fix the galaxy. Why do we have a nebula, like, all of a sudden? I mean, it's very pretty, but why is it there? Is our star field in the wrong place? No, it's not. Right, so the issue with the stars being in the wrong place is going to be something to do with this. Right, so that's just setting the colours and things. We don't care about that. What we do care about is that. So the galactic coordinates times the starfield scale. Now we know that's correct, because otherwise the holo display would be wrong. Okay, there's only one thing for it, and that's some debug spam. So all this code here, this is just dealing with the actual scale. So that's not a concern. So it's literally just this, and oddly enough, that's not something that's changed. Okay. Let the spam commence. You can be an odd pink colour today. Let's see where it's actually putting these stars. You're welcome, Don Lishko. See, coffee sounds nice, as does a nice cup of tea. Well, all those coordinates look good to me. Not wrong with them. Okay, Delta, have a good one. Thanks for watching. As soon as I've fixed this oddness, I shall stick a build out. Planet atmosphere's there. It's all good. Seems to me that it's drawing things further away than it should do. That might be part of the puzzle. Yeah, I mean, it shouldn't be drawing a K-class star all the way out here. It's nice to see the class working though. Presumably, Sol should say G2V. Hoorah! Right, okay, so Holo displays drawing stuff like way too close. Yeah, I've essentially compared it against like NASA photos and things and looked at what Earth looks like from space, from ISS, just trying to make it as realistic looking as possible. It's difficult because a lot of the pictures from space vary in terms of, you know, the colour of the blue and that sort of thing. So it's difficult to know exactly what you would see with your naked eyes, but I think it's a decent approximation. Leave that there for a sec. Let's get rid of some of these tabs, that's per usual. Right, so when we're doing our distance sort, we're taking our primary object, okay, we are setting K-class out that far. Perhaps that was a little optimistic in the old distance range there. Right, so why aren't we seeing, actually, no, I was going to say, we are only seeing manually created stars. We're not seeing any procedural ones. Let's move the ship somewhere else. Yeah. No, I will put my spam back on, actually. Return of the spam. So again, the coordinates look absolutely fine. It's not a coordinate issue. It's a why is it over there issue. Right, so let's us move the ship and zero that out a sec. Why don't we go? Let's go to 26,000 flat. So 670 light years away. Cheat our way over there. So we've got a lot more in the way of procedural stars. are we seeing them on the sensors? Yes, we are. Right, so we're definitely generating procedural stars, so that's good. And if we just do a quick scan of this one, see what the data looks like. That's good. It's doing its proper subclass. Okay, so at the risk of a massive crash, let's jump the ship to the center of the galaxy. Yeah, 1 light year away from Sag A. There's a lot of stars. Okay, so here we're fine. Yeah. Okay. So it definitely works near Sag A. Let's try moving away. Let's go 500 light years away. Interesting. Oh, my inner star system. That's unexpected. What were the chances of that? It's a very lonely star, though. It's got no friends. Right? So perhaps not 500 then. Why don't we go for 100? That was typing in a random coordinates and actually being in a star system is actually quite difficult because they're very quite spaced apart. Huh. So I think what's happening here is it seems to be offsetting every single star from 000 and not from the location of the ship. So it's not actually offsetting. Well, that's actually really confusing. So I think it's actually the live star field itself, which is not updating its position. It's evidenced by the fact that it's at 000 when it shouldn't be, which means where's our anchor? That. So I suspected it might have been something to do with this, but it's definitely not. Oh wait, hang on a minute. No, that can't be right. Just wondering whether this needed to be converted into centimeters, but no. Right, so we know that it's adding the stars in the right place relative to itself. So So obviously this is in local space relative to this blueprint, so that's working. Because when we're at 0, 0, 0 in galactic space, all the stars are in the correct place. And as we fly away from 0, 0, 0, all the stars kind of stay at 0, 0, 0, which tells us that it's not a problem with this blueprint specifically. It's a problem with how this is moving space. But Earth's in the right place. Yeah, it just needs to click. There is a key thing here that somewhere I'm missing. So it's obviously related to the data conversion. Yeah, it is. I think it's something to do with like kilometers to centimeters, and there's been a conversion there because one of the things that has changed is when we're generating the star systems, we are using a different scale now. So a lot of the data is using raw units rather than like a multiplier of a raw unit. Yeah, all that looks fine. See, what I find confusing with this is the fact that I'm going to run it again a sec. Is that the holo display is correct. So if the holo display is correct, then we know that the galaxy data is correct, because otherwise the holo display would be wrong. But we know that the star field is correct internally because it works when you're at Sat J. It's just not moving. So does that therefore mean that it's not actually moving itself around the galaxy like it should do? Because it should be offsetting itself opposite to where the stars are. So those stars over there are at 0, 0, 0. So if they're like minus 26,000 light years, then the actor that spawns the stars needs to be plus 26,000 light years, so that the stars are around where the ship is, because those stars are positioned relative to the actor, and the actor itself moves around as the ship moves around to simulate obviously flying through a live starfield. I suppose just to make sure that all works properly, let's just go to warp. Bye bye Earth. Okay, so we've passed outside of the Sol system now. Those guys over there are not moving at all relative to the ship, so question? Yep, seems to be. So if I were to target, I don't know, Procyon, for example. So that's 5 light years away. So we are getting closer to it, and the ship here should be flying towards it. Yeah, there we go. So you can see we are indeed flying towards Procyon. So we know that the galaxy data itself is sound, because otherwise that wouldn't be working. And neither would that be working. And indeed, when we get there, I expect to see a star. Almost there. So about 0.5 light years, we should enter the system. The star should appear like that. Disengage the autopilot and whiz past. Right, so we know that all of that is correct and as it should be. So it's definitely that the live star field is not updating, it's not moving. Let's just double check on that. It's just a target, so that's fine. Again, that should just be space targets. Yeah, that's fine. This is that one. Good night, Dave. Thanks for watching. So the only thing I can think of is that, that it's not snapping the target. Just verify that it is actually doing what it should be doing. Starship connected. Process of elimination. Okay, yeah, definitely. So that's working. It's not that. We're not going to have modular ship construction for quite a very long time. Probably even after the first DLC campaign. So you're looking at a couple of years, I would have thought. But in terms of upgrading what's in the stock ship, then yes, everything will be upgradable. It's a scale issue. I mean, that scale should match, which they do. So it's not the scale. Okay. Right, so if we keep a track of where the anchor actually is, then at the same time, we'll track where this is as well. So we have a looping function here we can use. Let's see whether they match. Yeah, doing some kind of a language model is something that would be really cool for the NPCs, so that they could have actual proper conversations. But we've got quite a few sort of prerequisites for that. Like, it needs to be a language model that runs locally. It needs to be lightweight, so it doesn't absolutely murder the GPU. And it needs to be trained on verifiably good data. And of course, we need to be able to train it on our own data as well. That's kind of where we're at with that. Yeah, so it looks to me that the vector of the live star field is different from the vector of the anchor it's supposed to be attached to, which is odd. Yeah, and the anchor seems to be moving independently of the, rather the star field is moving independently of the anchor, which it should not be. Very, very strange. Okay, well, I think it's about time I go take a break and see if inspiration strikes. Hey Devin, thanks for joining the stream, and sorry, bad timing because I'm literally just about to shoot off. BC5, yes. So the ship interior is a static environment, and the center of the world is the middle of the bridge. And that's the that's the space that you walk around and interact with. Now, space is moved around the ship. So Sad J is obviously 26,000 light years away, and we compress the scales to try and minimize floating point errors. So there is a smaller ship that's actually physically flying around that's invisible, that you can't see. And the galaxy is oriented based on this ship that's flying around. And that ship has all the physics interactions, and it can bump into things and all that sort of stuff. But yes, so in order for us to have such an immersive interior, it needs to be static, otherwise we can't have physics objects and that sort of thing. So moving space around the ship is the solution to that. And usually it works fine, but obviously it's having a bit of a hissy fit today. Yes, I shall go off and I shall scratch my head a little bit and see if I can work out what's going on with this. As soon as I fixed it, I shall put out a dev build, but I don't know how long that's going to take. But that is the only thing stopping a dev build at this point. Right, and I think on that happy note, I shall wish you adieu, and I shall catch you all again on the Sunday stream, usual time, 8 PM. Yeah, so bye for now, and I shall catch you in the next one.